Now let's solve these questions together. We have a transformer with 3,500 tons primary coil is designed to work from a 250-volt AC mains to give a supply of 10 volts to ring an electric bell. They now said which of the following is correct for this transformer above. They said a 3,500 tons primary coil, that is solution. A transformer with 3,500 tons primary coil. That is the number of what? The number of tons in the what? In the primary coil of the what? Of the transformer, NP. The number of what? The number of primary tons. That is what? That is 3,500. Is designed to work from a 250 volt to work from, this is actually the input what? The input voltage. The input voltage, which is what? And the primary voltage is also known as the input voltage. That is the primary voltage, also known as the what? The input voltage. Input voltage. That is equals to what? Equals to 250 volts. 250 volts. To give a supply, that is the output voltage. That is the secondary voltage. The secondary voltage, which is also known as the what? The output voltage. Output voltage equals 10 volts. Then answer which of the following is correct about this transformer. A, they said it is a step-up transformer. This is no. For a step-up transformer, the secondary voltage for step-up, if it is step-up transformer, for step-up transformer, the secondary voltage, that is the output voltage, is always greater than the what? Than the primary voltage. So which means this question, this particular transformer is not what? It's not a step-up transformer. It is what? It is a step-down transformer. Because for step-up transformer, the secondary voltage must be greater than the primary voltage. That is, the output voltage must be greater than the what? Than the input voltage. So here, the secondary voltage, which is the output voltage, must be greater than what? Must be greater than the input voltage for us to what? To have a step-up transformer. They said it is a step-down transformer. Yes, this is a step-down transformer. Because of what? In step-down transformer, the primary voltage, which is the what? Which is the input voltage, is always greater than the what? Is always greater than the output voltage, which is the secondary voltage. And if you see, the VP here is small, it is 250, while this one is 10. Then automatically this is greater than this. Then this particular transformer is a step-down transformer. Now you can let's check through the other options as well. They said it will work if connected to 250 DC mains. We all know DC means what? DC means direct current. Direct current. And transformer only works with what? It only works with alternating current. Transformer only works with alternating current, not what? Not DC. Then this one is also not an option. It will never work. This particular transformer will never work for DC mains because transformer is not designed to work for direct current. Transformer is designed to work with what? To work with AC mains. So that's why this is the reason why this is not an option as well. And the last option, they said no energy is lost in the transformer. It is not possible. Transformer lost energy, and this is one of the reasons why the efficiency of a transformer is not 100%, because transformer lost energy. And part of the energies that transformer lost, part of the reasons why the efficiency of a transformer is not 100% is because it lost what? It lost a lot of energy. And this energy it includes hysteresis loss. We have the flux leakage. Then we've solved this question now, which shows that this particular transformer is designed as what? As a step-down transformer. And the key take notes here is that for a transformer to be a step-down transformer, the primary voltage must be greater than the what? Must be greater than the what? The secondary voltage. Then if this happens, then this particular transformer is known as what? Is known as step-down transformer. So which means the primary voltage, don't forget, it's also known as what? It's also known as the input voltage. Input voltage. Why the what? The secondary voltage is also known as the what? The output. That is what is supply. The output what? The output voltage. This is the input. Therefore, for a step down transformer, the input voltage must be greater than the what? Must be greater than output voltage. And it will not work. Don't forget what I said earlier. I said transformer is not designed to work with what? To work with direct current. Transformer is designed for what? For an alternating current means, not for what? Not for direct current. That's why this is not an option as well. And for this, we said no energy is lost in the transformer. It is not possible. Energy is lost in transformer. That is why the efficiency of a transformer is not 100%. And part of this loss includes the flux leakage, the heat loss, hysteresis loss, cure loss. All of these losses are the what? They are the main reasons why efficiency of a transformer is not 100%. Now, using this same question again to solve these other parts, they said the number of turns in the secondary coil of the transformer is dash. What is the number of turns? And don't forget, they said a transformer with 3,500 turns primary coil. That is the number of turns in the primary coil. The number of turns in the primary coil is what? Is 3,500 turns. You can put it. You will see some questions. Some questions we said 3,000 widen. Some said turns. Some use what? Widens. They now said is designed to work from 250 volt. Don't forget what we said. We said this 250 is the what? Is the input voltage. That is the primary voltage. The primary voltage is what? Is 250 volts. 250 volts. To give a supply of this supply, to give a supply of 10 volt, that is the output. The what? This is the what? This is the primary voltage. This is the primary voltage. Why this is the what? The secondary voltage. The secondary voltage of 10 volt. They now said the number of turns in the secondary coil, that is the number of turns in the secondary, is what? Is unknown. And don't forget the short formula. We said to calculate the number of turns, then we have what? The number of primary turns divided by the number of the secondary turns equals to the what? The output, the input voltage, that is the primary what? The primary voltage, everything over the secondary voltage. Then we substitute all this into what? Into this particular formula. For the NP, the number of the primary turns, we have 3,500. That is 3,500 divided by the number of the secondary turns. That is what we are looking for. They said the number of turns in the secondary coil, that is the NS, to be equal the primary voltage, that is 250, divided by the secondary voltage, that is what? That is 10. Then here you can decide this cancel this. Then we have what? We have 3,500 divided by the what? The number of what? The number of secondary turns equals to what? Equals 25. You can set 25 over what? 25 over 1. Since 0 cancels 0. Then here you can cross multiply. When you cross multiply, you have what? 25 secondary turns equals to what? 3,500 times 1. That is 3,500. Then you divide both sides with this 25. That is what? 25 number of secondary turns divided by 25 equal 3,500 divided by what? Divided by 25. Then this cancel this. We have what? The number of secondary turns to be what? 25 in 3,500 is actually 1,040. 140. 140, it means 140 turns, which means there are what? The number of turns in the what? In the secondary coil of the transformer is what? Is 140 turns.